What if the very first ingredients for life didn't form on Earth at all, but were delivered here by comets already partially assembled in the icy darkness of deep space? In a stunning leap for astrochemistry, scientists have uncovered a molecular treasure trove around a young star named V883 Orionis. Located 1,350 light-years away in the Orion constellation, this infant star is encircled by a swirling protoplanetary disk of gas, dust, and ice. Exactly the kind of environment where planets and possibly life take shape. The real surprise? Within that disk, researchers detected 17 complex organic molecules, some never previously observed in such settings. Among them were ethylene glycol, the same compound used in antifreeze, and glycolonitrile, closely related to essential components of DNA and amino acids. These aren't just exotic molecules, they're fundamental steps on the path toward life. And for the first time, they've been found not in distant clouds or ancient meteorites, but in a newborn star system. This discovery challenges one of astronomy's long-standing assumptions, the reset hypothesis. According to that theory, the violent emergence of a star annihilates complex molecules formed earlier, wiping the chemical slate clean. Any life-related compounds would need to reassemble in the aftermath amid chaotic rubble and intense radiation. But V883 Orionis tells a different story. Instead of obliterating these organics, the transition from cold interstellar cloud to fiery young star seems to preserve and perhaps even amplify them. Scientists now suggest that there's a continuous chemical thread stretching from early star-forming clouds to mature planetary systems. The implication? Life's raw ingredients might be universal, seeded throughout space as part of the natural evolution of stars. That didn't come without effort. The breakthrough was made possible by the Atacama Large Millimeter Submillimeter Array, ALMA, high in Chile's desert. This observatory's precise antennas can pick up the faint signals emitted by molecules at millimeter wavelengths, especially as they warm up near young stars like V883 Orionis. Here's where it gets fascinating. V883 Orionis is still pulling in gas from its surrounding disk. These episodes of rapid growth unleash intense energy bursts that heat the disk. As temperatures rise, ices melt, and molecules trapped within them evaporate into gas, broadcasting their spectral signatures, signals that ALMA is perfectly tuned to capture. The results were striking. A vibrant mix of organic compounds, ethylene glycol, glycolonitrile, methanol acetaldehyde, each one a tiny rung on the biochemical ladder. If they're abundant in a system this young, could they be common throughout the galaxy? Every time a star is born in a nebula, it may already come equipped with a molecular toolkit capable of sparking life. Far from rare anomalies, these molecules could be standard features of cosmic evolution. Our own solar system backs this up. Ancient meteorites have been found to contain amino acids, sugars, and nucleobases, the molecular letters of life. Comets, those frozen remnants from our system's birth, preserve similar chemistries. As they near the sun and heat up, they release gases that glow, revealing their molecular contents, sometimes even sampled directly by spacecraft. This consistency points to a profound truth. If Earth's life arose from such space-borne compounds, similar scenarios might unfold across the universe, on icy moons, in hidden oceans, or on rocky worlds orbiting distant suns. Some molecules near V883 Orionis, like glycolonitrile, are just one reaction away from forming simple amino acids like glycine and alanine. Others are closely linked to adenine, a building block of both DNA and RNA. It's as if the universe is writing the same recipe for life again and again in interstellar clouds, planetary disks, comets, and rocks. This rewrites our understanding of life's chemical timeline. Scientists once believed that complex organics could only emerge under specific, planet-based conditions over millions of years. But V883 Orionis suggests otherwise. Space itself appears capable of assembling life's ingredients long before any planet forms. And this could just be the beginning. The current detections, though groundbreaking, may only hint at a deeper molecular complexity. The data from V883 Orionis are still being examined. Future high-resolution studies may uncover even more sophisticated compounds, perhaps full amino acids. Meanwhile, next-generation telescopes will peer into other young systems, expanding the search. So next time you gaze up at Orion's belt, imagine what's unfolding inside those stellar nurseries. Molecules coalescing, chemistry evolving, the seeds of life already in motion. Because life doesn't start on a planet. It starts in a cloud, sculpted by radiation and time, etched into ice and carried across the galaxy, written in a molecular script as old as the stars themselves.
Imagine traveling 10,000 years into the future. What would our planet look like? Would there be giant volcanoes? Would most of its surface be covered with oceans? And what if we traveled even farther, 1 billion years in the future? Now, Earth is about 4.5 billion years old, and when it formed, it looked very different from now. It was an extremely hot world, drowning in molten magma. Then, over the course of a few 100 million years, the planet began to cool. That's when the oceans filled with liquid water appeared on its surface. Heavy elements, initially floating on the surface of this bizarre Earth, started sinking past the oceans and magma toward the center of the planet. Earth became layered. The outermost layer was a solid covering made out of relatively light material, while the denser substances sank to the center of the planet. That's how it all began. Now, speaking about such a distant future, and 1 billion years is no joke, the chances that humans will still be around are very slim. You see, there are quite a lot of threats the human race might face in the process of its development. Climate change, overpopulation, falling asteroids and comets, ice ages, the sun getting hotter. Let's say you've got your hands on a time machine, and on your way to see what our planet will look like in 1 billion of years, you make a few stops. And the first one is 10,000 years into the future. One of the main changes is the appearance of people. Apparently, genetic differences are no longer regional. Such traits as skin tone or hair and eye color are evenly distributed around the globe. 20,000 into the future, and you don't understand people anymore. None of the current languages is recognizable, and the language people speak only has 1% of the present-day vocabulary. Moving further, 50,000 years into the future, and you realize with horror that a new ice age has started. Niagara Falls have eroded, and a day on Earth has increased by 1 second. Your next stop is 250,000 years from now. The landscape of the planet has changed a bit. For example, a new island has formed in Hawaii. After exiting your time machine 500,000 years into the future, you realize you might have made a mistake. Fires are raging all over the planet and the air is nearly unbreathable. The reason is a giant asteroid. People didn't manage to prevent it from hitting Earth. You hop into your time machine and set the timer to 1 million years from now. It seems you're out of luck. This time, it's a massive supervolcano eruption, spewing out hundreds of cubic miles of ash. It's already produced enough lava to fill 75% of the Grand Canyon. 2 million years into the future, and people have created settlements all over the solar system. Humans look different on different planets and moons since their bodies have adapted to particular conditions existing in those regions. 50 million years into the future, and you see that Earth is still changing. A massive part of Eastern Africa has broken off, forming a new ocean basin. Africa has crashed into Eurasia and closed off the Mediterranean Sea. A new mountain range, higher than Mount Everest, has formed between these two landmasses. Also, Mars has collided with its moon and got a cool ring system, just like Saturn. You make a stop 600 million years into the future and find out that a gamma-ray burst has occurred around 6,500 light-years away from Earth. Luckily, it hasn't hit our planet. Otherwise, there would no longer be the protective ozone layer, and it would have caused a mass extinction. Also, the moon is now so far from Earth that there are no more total solar eclipses. And now, your final destination, Earth 1 billion years from now. With bated breath, you leave your time machine and freeze in shock. Our once beautiful planet has turned into a lifeless desert. The levels of carbon dioxide have dropped dramatically, and there's no photosynthesis anymore. It means that free oxygen and ozone have disappeared from the atmosphere, and there's no more complex life on the planet. Plus, the sun's luminosity has increased by 10%, making average temperatures on Earth rise at least twice. You feel as if you're standing in a giant damp greenhouse. The oceans have evaporated, leaving a few small pockets of water at the poles. What about people? You won't find them on Earth. By now, they have already colonized some faraway planets in faraway galaxies. You should probably leave this inhospitable world too.
Imagine this. A sleek spacecraft lands back on Earth, carrying with it tiny pieces of rock and dust from the surface of Mars. Inside those rocks, frozen in time, could be the greatest discovery in human history, or the biggest threat. We've seen it all before in sci-fi. Aliens hiding in plain sight, taking over our bodies, our minds, our world. From the eerie replacement of humans in Invasion of the Body Snatchers, to the grotesque shapeshifter of The Thing, fiction loves to terrify us with stories of life from beyond. But let's be honest, nobody really believes an alien's gonna crawl out of a pod and eat your face. But what if the real threat isn't something big and monstrous? What if it's microscopic, silent, invisible, and real? In the next decade, humanity is planning something extraordinary. A mission to Mars will not just explore, it will bring pieces of the red planet back home. NASA and ESA are already preparing for the Mars sample return mission. It sounds like a huge leap forward in space exploration, and it is. But with it comes a question that scientists are only beginning to wrestle with. What if something is alive in those samples? And no, we're not talking about Martian octopuses or intelligent civilizations. We're talking about microbes, bacteria-like organisms that could have survived for millions, even billions of years beneath the Martian surface. If they exist, and if we're not careful, they could interact with our biosphere in unpredictable ways. That's why scientists around the world are racing against the clock to figure out how to detect life in Martian rocks without destroying the precious material in the process. Because here's the catch. Once we bring Mars samples back to Earth, we won't get a second shot. These fragments of another world are irreplaceable. Enter Yohei Suzuki, an associate professor at the University of Tokyo, and his team. They've developed a cutting-edge method that could change everything. It's called optical photothermal infrared spectroscopy, or OPTIR for short, and it can detect signs of microbial life in rock samples without grinding them into dust. Let's break this down. Traditional methods, like electron microscopy or nanosims, can reveal microscopic life, but they usually destroy the sample in the process. Not ideal when you're working with a rock that traveled 300 million kilometers to get here. OPTIR, on the other hand, only requires a thin slice of the sample, about 100 micrometers thick, and leaves the rest untouched. It's like giving a biopsy to a rock without killing the patient. What's more, the resolution of this technique is insanely precise, down to 0.5 microns. That's small enough to detect microbial cells and even distinguish between different types of biological molecules, like proteins. In tests using Earth rocks that are 100 million years old, Suzuki's team was able to identify microbial life still locked inside clay-filled fractures. These aren't just guesses or blurry images. The spectral fingerprints they captured, patterns of light and heat, match known biological signatures. It's like finding a fossil, but on a molecular level. But wait, it gets even better. The rocks they used as Martian analogs weren't chosen at random. They specifically selected basalt, a type of volcanic rock common on both Earth and Mars. In fact, the Perseverance rover has already collected basalt samples from the Jezero crater, and those are the very samples expected to return to Earth. Suzuki and his team are essentially rehearsing with Earth stand-ins before the real show begins. So what does this mean for us? It means we're on the brink of possibly answering one of the most profound questions in human history. Are we alone in the universe? Are we alone in the universe? Are we alone in the universe? But it also means we have to proceed with incredible caution. The organization overseeing planetary protection, COSPAR, has classified this as a Category 5 Restricted Earth Return mission. That's as serious as it gets. It means that the samples must be sealed, sterilized if needed, and analyzed using only the most advanced, non-destructive techniques available. The goal? To reduce the risk of accidentally releasing an alien microbe into Earth's environment to 1 in a million. That's right, scientists are literally working to make sure that the odds of missing a living organism, if it's in there, are less than 1 in a million. So while the movies like to show aliens crashing into Earth in a ball of fire, the real invasion, if it happens, might arrive in a test tube under tight quarantine, escorted by men in hazmat suits. And yet, that test tube could hold the answer to everything. Life on Mars. A second Genesis. Proof that Earth isn't the only cradle of biology in the cosmos. For now, it's a waiting game. Scientists continue to refine their instruments. Engineers prepare the containment systems. And somewhere, millions of kilometers away, little pieces of Mars are waiting to come home. And when they do, we'll be ready. We hope.
An invisible star, a red dwarf, hides 124 light-years away from us. And orbiting this faint celestial body is a planet that could fundamentally alter our understanding of life in the universe. Its name is K2-18b, and this is not its first time in the scientific spotlight. But now the reasons are far more compelling and perhaps historic. A team of astrophysicists from Cambridge, working with data from NASA's ultra-sensitive James Webb Space Telescope, has discovered chemical compounds in the planet's atmosphere that, on Earth, are produced exclusively by living organisms. The substances in question are dimethyl sulfide, DMS, and dimethyl disulfide, DMDS. On our planet, these gases are typically associated with marine plankton and certain bacteria. What they are doing in the skies of a distant exoplanet is still a mystery, but a mystery that might point toward extraterrestrial life. Professor Niku Madhusudan, the lead researcher on the project, calls this the most convincing evidence to date of potential life beyond Earth. If our interpretation is correct, he says, we could confirm it within a year or two. Perhaps the most astonishing part of the discovery is the quantity. The concentration of DMS found in the atmosphere of K2-18b appears to be thousands of times higher than equivalent levels on Earth. If this is not a mistake or observational artifact, we may be looking at an entire world teeming with life. But scientists, including Madhusudan's own team, urge caution. The current data, while impressive, still falls short of the rigorous standards required for a formal scientific discovery. To claim definitive proof, they need a statistical confidence level of 99.9999%, known as the 5 sigma threshold. At present, the result stands at 3 sigma, or 99.7%, a significant improvement from previous estimates of 68%, but still not enough. Other researchers and independent experts echo the cautious tone. Astronomer Catherine Hamans, for instance, emphasizes that even with reliable data, we cannot say with absolute certainty that DMS and DMDS originate from biological processes. The universe is vast and filled with exotic phenomena. We still don't fully understand what can happen inside such alien worlds. The intrigue surrounding K2-18b isn't based solely on its mysterious chemistry. The planet is roughly 2.6 times the size of Earth, and data suggests it has an atmosphere where ammonia is notably absent, a gas that should be present in a dry, oceanless world. This absence points to a compelling hypothesis: the presence of a vast subsurface ocean. And where there's water, the possibility of life follows. However, alternative scenarios remain. The ocean might consist not of water, but of magma, a revelation that would crush hopes for life. Adding complexity, the planet's very structure is under debate. Some models describe K2-18b as a mini-gas giant with no solid surface. That would render the world utterly inhospitable to life, at least any form of life we currently comprehend. Still, despite all the ifs and buts, the scientific community remains deeply intrigued. The Cambridge team is collaborating with other research institutions to investigate whether the detected molecules could be synthesized through non-biological means in laboratory settings. If such synthesis proves impossible, the case for a biological origin becomes far stronger. Professor Subir Sarkar, another member of the project, is careful with his conclusions, yet he acknowledges that the possible presence of an ocean makes K2-18b one of the most promising candidates in the quest for alien life. His message is simple and clear. Watch this space. Cambridge astrophysicist Oliver Shortall, however, brings us back to reality. He reminds us that all of our knowledge about distant exoplanets is drawn from faint threads of light passing through their atmospheres. Interpreting those signals is like trying to read a smudged and half-burnt map, prone to error, to bias, to misinterpretation. Each promising signal could be either a whisper of life or a trick of the cosmic light. Yet the implications are impossible to ignore. Even the slightest probability of a biological origin for these gases elevates the conversation. This isn't just about chemistry, it's about existence. About the possibility that we may not be the only ones looking up into the void. Public curiosity has surged alongside scientific interest. News of K2-18b's chemical profile has lit up headlines, podcasts, classrooms, and conspiracy forums alike. Some hail it as our first real evidence of alien life. Others urge restraint, cautioning against the seduction of sensationalism. But in a world starved for wonder, K2-18b delivers, even if only as a promise. Further missions are already being drafted. Telescopes in space and observatories on Earth are preparing to lock their gaze on this distant enigma. New instruments, refined spectrographs, and smarter algorithms will seek to strip away more layers of the mystery. Every spectrographic fingerprint, every spectral dip in starlight brings us a little closer to confirmation, or recalibration. Science moves not with leaps of faith, but with patient, deliberate steps. And yet, some steps feel bigger than others. When we look at K2-18b, we don't just see another planet. We see a question written across the stars. Are we alone? As Madhusudan puts it, decades from now, we may look back at this moment and realize it was the beginning, the dawn of a new cosmic chapter. The moment humanity first saw the glimmer of a living universe beyond the solar system. The discovery hasn't been made yet, but the journey has begun, and that alone is already extraordinary.
New research suggests that Mars might have all the necessary conditions for the appearance of life. Does it mean aliens could be already waiting for us on the red planet? Let's figure it out. On Mars, there are just the right conditions for photosynthesis beneath dusty ice layers in its mid-latitudes. And photosynthesis, the process used by plants, algae, and cyanobacteria to turn light into chemical energy, requires water and sunlight. On Mars, a thick layer of ice might filter out harmful solar radiation while letting enough light through to enable photosynthesis, creating what researchers call radiative habitable zones. This doesn't mean that, at the moment, life exists or has ever existed on Mars. At the same time, the findings give scientists clues about where to search for potential signs of life. Both Earth and Mars lie within the Sun's habitable zone, where temperatures can support liquid water. But while our planet's surface is covered with huge oceans, Mars appears dry and desolate. Yet evidence from NASA missions like Curiosity and Perseverance suggests it wasn't always this way. Ancient lake beds and river channels show that water flowed on Mars billions of years ago. Today, water exists on Mars primarily as ice, often in surprising locations. Scientists believe Mars lost its liquid water when its magnetic field faded, which led to its atmosphere getting stripped away by solar winds. With little atmosphere left to trap heat, water vapor escaped into space, leaving the surface cold and dry. Without an ozone layer, Mars also faces intense ultraviolet radiation, which destroys the complex molecules essential for life. Mars gets about 30% more harmful UV radiation than Earth. But dusty ice layers could shield potential habitats from this radiation while still letting in enough sunlight for photosynthesis. Using computer simulations, researchers found that dust within Martian ice could cause it to melt from below, forming thin layers of liquid water. These pockets could be shielded from evaporation by the overlying ice, creating the two essential ingredients for photosynthesis: water and sunlight. Past studies also suggest that even small amounts of dust, less than 1%, in dense Martian snow, can enable melting in mid-latitudes. Observations of exposed dusty ice near Martian gullies also support the idea that these conditions could form shallow liquid water layers under the surface. At the same time, the amount of dust in the ice plays a critical role. Ice with too much dust blocks sunlight, while ice with just the right amount, from 0.01 to 0.1%, can create habitable zones at depths of 2 to 15 inches. Cleaner ice could allow these zones to form deeper, between 7 and 10 feet. As for Mars's polar regions, even though they're rich in ice, they are likely too cold for this melting to occur, making mid-latitudes a more promising target. Interestingly, similar habitats exist on Earth, providing an analog for what might happen on Mars. On Earth, cryoconite holes form when dust and sediment heat ice surfaces, melting them enough to create pockets of liquid water beneath. These translucent ice layers allow sunlight to go through, and researchers have discovered microorganisms living in these shallow subsurface environments. While they go dormant in winter, when sunlight returns in the summer, it reactivates these tiny ecosystems. While this research doesn't confirm the existence of life on Mars per se, it does open up new avenues for exploration. Understanding how dusty ice interacts with sunlight and melts could help identify potential habitable zones on the red planet. The research team is planning to refine their simulations to better pinpoint where and when melting might occur on Mars. They're also recreating these conditions in the lab to study them in greater detail. This work could provide important insights for future missions looking for signs of life on Mars. With the help of NASA's Juno mission, scientists have just put together the first ever 3D radiation map of Jupiter's system, and it's amazing. For one thing, the map shows how intense the radiation is near the orbit of Europa, the fourth largest of Jupiter's moons. The map also uncovers how some of Jupiter's smaller moons, which hang out near its rings, actually shape the radiation around them. But first thing first, to pull off this cosmic feat, astronomers used data from two high-tech instruments on Juno: the Advanced Stellar Compass from the Technical University of Denmark and the Stellar Reference Unit from Leonardo Spie in Italy. These tools were originally designed to help Juno navigate deep space, but the smart folks at NASA managed to repurpose them as radiation detectors. Now, you might be wondering why such a map is so groundbreaking. It's the first of its kind to capture radiation at such high energies, giving researchers important insights into Jupiter's radiation zones. This info will also be super helpful for planning future missions to explore Jupiter and its moons. Before figuring out why we need this data so much, let's talk about how Juno does its magic. The Advanced Stellar Compass is like Juno's eyes. It uses 4 star cameras to lock onto stars and keep the spacecraft on course. These cameras also pick up on high-energy particles that slam into Juno. When this happens, the particles leave little trails in the images that look a lot like fireflies. By counting these fireflies, scientists can figure out how much radiation is out there. Juno's ever-changing orbit allows it to check out almost every corner of Jupiter's space. That's how we've learned that there's more high-energy radiation near Europa than anyone expected. More high-energy electrons are zapping the side of Europa that faces its orbit, thanks to Jupiter's speedy rotation. And just like the compass, Juno's Stellar Reference Unit is pulling double duty. The data from these instruments shows that Jupiter's shepherd moons, which help keep the rings in shape, are also playing a big role in the planet's radiation environment. When Juno flies close to these moons or through dense dust, the radiation levels suddenly drop. But let's get back to Europa and its radiation levels. Why are we so interested in this moon? All because one day, we might make this place our new home. This moon is one of the most promising places in the solar system to find environments suitable for life beyond Earth. Terraforming Europa is a hypothetical process that would make the climate of this Jupiter satellite habitable for humans. Even though Jupiter has a very large radiation belt, which probably destroyed all life forms on Europa, if there were any, some scientists hope that it might be overcome with the help of space technology. Terraforming Europa would require serious changes. We would need an ozone layer, which would absorb ultraviolet radiation and reduce the amount of harmful radiation reaching the surface. Also, we wouldn't be able to live comfortably without a magnetic field, so it would need to be installed. The oxygen percentage would need to be just right. On Earth, it is about 21% of the atmosphere.
and we would also need to find a way to increase atmospheric pressure and to remove excess surface water or ice. But why would we need to do all this? Astronomers predict that in 3 billion years, the sun will become brighter by 33%. The sun's warming and increased solar radiation will cause Earth's oceans to evaporate. The habitable zone will move further from the sun. Sadly, even if Europa in the future receives the same gravitational kinetic and electromagnetic energy as Jupiter, the sun might still be too hot for this moon to be habitable. Plus, the level of ionizing radiation on the surface of Europa is equivalent to a daily dose of about 540 rad, where rad stands for a radiation unit. To understand how much this is, let's take the following example. We are all constantly exposed to natural background radiation from the Earth and space. The average dose of such background radiation is lower than 1 rad per year. A lot of X-ray analyzers barely reach 10 rad. This is still safe for our body. We have adapted to such doses of radium. But receiving 100 rad leads to radiation sickness and greatly increases the risk of cancer. So, as you see, a day on the surface of Europa is bound to cause a serious illness with dramatic consequences. Interestingly, some animals can deal with radiation much better than humans. For some cockroaches, a lethal dose can reach 100,000 rad, and 500,000 rem is fatal for only 50% of irradiated tardigrades. In other words, it is possible to imagine life forms on Europa, but for humans to live there, we must reduce the radiation level first. According to some experts, UV radiation might be blocked if upper atmospheric components of Europa provided some protection. Does it mean we might make Europa habitable in the future? I guess we'll just have to wait and see.
In the middle of the previous century, flying saucers were constantly making headlines. America was going through a surge of reported UFO sightings. So it shouldn't probably come as a surprise that the American authorities, namely the US Air Force, created a couple of short-lived programs. Those were Project Sign and Project Grudge, and their main goal was to look into that phenomenon. These programs were followed by likely the most famous of them all, Project Blue Book. It was a large-scale government study that lasted from 1951 to 1969. The initiator of this program was Major General Charles P. Cabell. He was a former intelligence director of the Air Force. Project Blue Book scrupulously gathered over 12,600 reports about people seeing bizarre unidentified objects in the sky. After thorough research, it was determined that most of those had natural, quite mundane explanations. As for the rest of the reports, the members of Project Blue Book simply didn't have enough data to evaluate them. That's why support for their efforts dwindled. Officially, Project Blue Book was closed in December 1969. But apparently, it didn't make American authorities lose interest in UFO sightings. Because in mid-December 2017, the world found out that they had secretly launched one more UFO research program in the late 2000s. Accordingly to certain documents, American authorities spent around $22 million over a 4-year span on a project called the Advanced Aviation Threat Identification Program, aka AATIP. This project was started in 2007, and its main goal was to study UFO phenomena. Most likely, all this activity was triggered by the 2004 Tic Tac incident. That's when a few US Air Force pilots spotted unidentified flying objects off the coast of California. They captured them on video. None of the pilots could figure out what these objects were. They behaved in a weird way, as if our laws of physics didn't apply to them. They were reportedly flying extremely fast and rotating in unpredictable movements. It looks as if after that incident, American authorities decided to investigate whether those objects could be identified or not. And if not, they were eager to know where they had come from and if they had been a threat. When the New York Times story about the new project broke, officials announced that the study had been terminated in 2012. However, there were people who claimed that the program was still ongoing.
One of those was a military intelligence official running the program until they quit in October 2016. In any case, let's have a closer look at this mysterious program. Indeed, the areas of research funded by the project resembled things you could find in Star Trek. For example, one grant was for the study of traversable wormholes, stargates, and negative energy. This study was conducted by Eric W. Davis of EarthTech International Inc. Another grant sponsored the research of invisibility cloaking. One more area of study included warp drive, dark energy, and the manipulation of extra dimensions. This research was conducted by a theoretical physicist and director of the nonprofit Icarus Interstellar. As we've already mentioned, all these studies received at least $22 million of funding, but this sum could have been much bigger. No one has revealed why or how these studies were given such huge grants under the AATI program. The results of the study aren't known publicly either. The criteria for choosing these fields of research could be that warp drives and stargates might be useful for extraterrestrial civilizations traveling interstellar distances to visit our planet. Still, some people are not amused that such questionable fields of study were receiving substantial government funding.
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede, and it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 UF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the Sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 LF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the Sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus,
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that. Perhaps we've all stopped to think at one point about what it would be like to live on another planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the stars in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they have found a new planet that might be able to support life. They call it TOI 700e. E is roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they call TOI 700d. But this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the conservative habitable zone. In simple terms, scientists aren't sure whether life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have some options. The two planets are in a solar system that's only 100 light-years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space and thrive for long periods of time. And history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technologies help us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it could take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, supersonic aircraft, but it's not the same. There's quite a difference, actually. Light is about 1,000,000 times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that's not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go up to about 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret Option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh. Instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets in through the windows every day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life. But if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. So the next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, we don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low. But if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off of their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then, that would be a bad thing too. We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So, Perseverance went to the delta. The row wasn't easy, though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero. And that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grain than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look.